So hey guys, and welcome to Messed Up. This has been a so much long time since I uploaded a video. So this video is all about the SolidWorks. I cover very basic concepts. So if you are a very beginner and if you want to learn things, then this video is exactly for you. In this video I cover 2D, 3D sketches, modeling, assembly, and I have also included the bonus section of weldment and surfacing. So if you are a Hindi speaker, there is already a playlist. You will see the link on the screen. Otherwise, if just go forward. So as soon as this you complete the video, I would say go for the projects. So there are many project videos in our channel, so you can visit them, and we will be uploading more future advanced videos, including in molding, plastic, sheet metal. And as you know, this video is meant for the beginners, so I have left quite a lot of things, so I will cover them in future videos. So if you have any doubt, anything that you want me to make a video on, you can just tell me on the comment section, or you can follow our Instagram page and tell us there, and we will make a video on that. And yeah, let's go. And if you haven't subscribed yet, subscribe our channel, and let's start the tutorials. So hello everyone, and this is the first screen that you see when you open SolidWorks. So I'll be going quickly through the user interface of the program. So here SolidWorks welcomes you, and you see home, recent, learn, and alerts. So let's just go one by one. So in home, you got the new option where you can create new part, assembly, or drawing. Parts are actually the 3D files that we'll be creating here in our tutorials, and the assemblies are made using these parts. Or you can also download parts from the internet for the assembly, and you can create an engineering drawing from these parts or assembly. And next is the open, where you can open any old SolidWorks file. You can also import a few models which are not from SolidWorks, for example like STL file, IGS, and a lot of them, which I will cover later in the import section. And next is the recent. Here you see your recent file which you have worked on it. Next is the learn. Here you see some pre-modified tutorials from the SolidWorks. And next is the alert, if there is an update on the software that you will see here. Okay, so I will go to the home and click on parts. So when you click on the parts, it takes you to the section where you can create new parts for yourself. So first, okay, so this section is called the ribbon bar, where you can see a lot of options. So these are the tabs naming, features, sketch, and evaluate. A lot of them are here. So if you want to make a sketch, you can choose any of the options. So this is the ribbon bar, and this is actually the feature manager tree. Here you see whatever you do here with your part using these particular tools, that will be written over here, and you can also modify it. And the next important thing which you should take care of is the units. You should always know what units you are working on, either it's English units or the ISO units. So I basically work with the meter, kilogram, and second. Next is these in the right hand side. You just click here and you see a lot of options here. So in the first section is the SolidWorks resources. You can get a lot of them, so you can do a benchmark test here there of your system, and you can also get a 3D experience. And you can also check out your subscription services. 3D experience is actually that you can know about the 3D models. You can find 3D models on the internet and download them and use them here. Next is the design library, which you will be using quite often, and this is a very important tool. For example, if you are creating a model which needs fasteners and tools like nuts and bolts, you can just get them from here. So design library also contains a lot of things like features, annotations, and other things. So let's just check out the toolbox very quickly. You just click here and you will see the units. These are country wise units, so but I will go for the NSI metric, that is international standard. For example, if I need bolts and screws, I can just go for any of them which I like, and you can just drag and drop here with what you need. View palette gets active when you work on something. Next is the visualization tab. So appearances are actually used to So if you, for example, if you are making anything, then a part which is made of aluminum, and you want to give it the look of aluminum, you just go to metal and click on the aluminum, and you can see a lot of options. You just drag and drop on the part. One thing to be taken care of, that it actually gives the appearance, it does not give property to the material. And if you want to give the property, you can just click here and edit material here. So here you can add the properties, whatever property that you want to give to your part, that you can do here. Here carbon fibers are also available, so it gets updated with the server. Next is the scenes. Scenes are actually the background that you want. For example, if I want some studio scene, you can just click here and drop. You can see the whole scene has changed. So this is what you do. You can just change your scenes here. Next is the decal. Decal means the logos or anything that you want to apply over your parts, that you can do. Next is custom properties. It is actually used to give naming and other options to your part. I will be discussing it later. 3D experience I have already told you. And the last is the Solidworks forum. As the name suggests, this is the same thing. So you can see updates from the Solidworks community, which is pretty much large. And if you have any problem, you can just search here, and you can ask even your own questions. Just click here and it will take you to the Solidworks website. You type your question and ask it. People will answer it for you. So for this tutorial, pretty much it. And in the next tutorial, I'll be telling you about how to import files and other cool stuff. Okay. So hello everyone. In this tutorial, I'll be importing our first file in SolidWorks, and we'll be navigating through it. So as in the last, I was working with this particular document. So there are two ways to import your file. For example, if you have been working on that file earlier, then you can just go to recent and import just by clicking here. Otherwise, you can click on open, and it will take you to your Explorer, and you can open whatever you want. So let me show you one thing. Now I have two files here. The first one is the assembly, and the second one is a part file. So initially I will just go for the part file. You can open any of these using that, and click on the file and just open, or double click on that, so it will open. Okay, so the file is here. Now let's just learn few basic controls that you will need. So if you just scroll up and scroll down the central wheel of your mouse, it will zoom in and zoom out. So if you want to see a particular section of your geometry, for example, if you want to see the top of this particular cylinder, the hole, then you just place your mouse there and scroll down, and it will zoom in at that particular section. So wherever you want to see a part, you just take your cursor over there and scroll up and down, and you will see your file. Next is navigating in 3D. So if you want to navigate in 3D, just press the central mouse wheel button, and if you do the left and right, then you can see it moves like this. And if you do it up and down, then you can see the other sides as well. So scroll in, scroll up for zooming in and zooming up, and if you press it and move it in upward or right or left or right direction, then you can just move it. Now next is okay, so let's just check out these options, which are quite important. Next is the zoom to fit. Okay, when it comes to just click on it, you can see it just brings you to the normal mode. And for example, if you are just here, you stuck here, and you want to go back to the normal mode, you just click here and it will take you to the normal mode. And the next option is the zoom to area. And if you want to look at a particular section of the geometry, for example, if I want to look at this particular corner, I just can click and drag, and I will have that area. You again go to the back of the area, you rotate it, and for example, if you want to look into this hole, you just click here and just you are there. Okay, the next is a previous view, and it will switch to your previous view, whatever you are doing. Next is the cross-section view. Cross-section view is pretty much important in the assemblies and also the parts. What it does, you can cut out some of the part and work on the left part, and you can come back to it anytime. So for example, you can just easily see that I can remove any part, but it is just from the visual point of view. Actually, you actually do not delete that. So you can change your plane from here. You can see. Okay, so this is what you can do. You can just, when you are done, for example, you want to work on this particular plane, but when you will try to work on this plane, it will go to the normal, and due to this particular section of the part, you will not be able to work on that. So you wish that this particular section gets hidden, and then you can work on it. So if you want to work on this part and you want to hide this easily, what you can do, you can just rotate your plane and take it here. Now you can see you can work on it, right? So you can work with your cross-section plane just by using these angle handles, using this, or you can put your angles from here, and this is how you can do. And when you're done, just click OK here. Now you can easily work on it, and when you're done, just click. Next is okay, dynamic annotations, which will come later when you will be going for the dimensions. Next is the views. So there are few standard views which we actually work with. For example, if you want to go to the top view, this is the top view. You can come to the side view, and you can also work on the 4 tabs at one time. For example, you can see we have all the views, side, front and top. You can work in any of them. When you are done working, then you can just come here and again switch to any normal one, and here you can decide the number of tabs, and just you can come to the first one. What kind of view do you want? For example, in Edit there will be no corners, so okay, here you can see the corners comes in, and in this one in Edit there is no corner, there are hidden lines removed. You can apply it, you can just see these lines. And if you want to see the lines of the hole that it passes through, you can switch to this hidden line visible. You can see the holes. Hidden lines are in dotted mode. And the next is wireframe. So basically I prefer this shaded with edges mode because it gives a lot of detail. And next is what kind of parts that you want to see and what you don't want to see. Next is the edit appearance. So edit appearance I have already discussed in the last section. When you click on the edit appearance, this particular section comes in. For example, if I want to apply metal, the bronze, so I like this, you just have to put in it and the bronze is applied. It looks pretty cool actually. Now you can also change your color from here, whatever color do you want, or you can just apply the natural one. So I will leave it here. Next is the background that we have accessed here. So few are here that you can see, and if you want more of them, you can just come here and okay, if you want more, then you can come through just easily to the scenes here. You can just apply whatever you want, even like this. Yes. Now the next option is, okay, I will leave it to the default. Next is the few modes like shaded. If you can have a shadow mode, occlusion, perspective. But what happens that you can apply any of these, but these particular views take a lot of computation power. So if you want to fast in your work, then you can just disable all of them. So that's what I do. And then last part of the video is how to export your file. So if you want to export file, go to the file, and yes, if you want to save it as a Solidworks file, as that is the SLDPRT file, you just click on save and it will be saved. Okay. Now, but if you want to change the format of the file, if you want to save it in formats like IGES files or STL file that we use to 3D print, so you can just select your file. For example, if I want to save it as IGES, you just click on here, name it, and you just click on save. So it will be saved as a IGES file. So this is it. Now you know how to navigate and import and export. So in the next tutorial I'll be starting the basic sketches. Okay, so welcome back guys. In this tutorial we'll be creating our first 3D model. So just click on it. We'll have a new part file and okay. Now wait for it to open. Now we are in the sketch mode and we want to make a sketch. So you will need a plane on which you will make a sketch. You can pick your plane from here, that is front plane, top plane or right plane, whatever you want. So if you want to, for example, if we want to make a sketch on the front plane, we can click on it and you can see a little option that says sketch. You click on it and you will enter the sketch mode, or you can just come over here and just click here and it will take you to the front plane. Now when you are in a front plane, so right now we are in a sketch mode. When you enter sketch mode, you see two options over here. This will take you out of the sketch mode and keep your sketch, and it will exit without saving. So let's just make a rectangle here. Now this is if you just put on it, you will see it's a corner rectangle. So you just define two corners and you can make a rectangle. You can also see the options of making a rectangle here. So the detailed discussion of sketches will be in the next section. So we'll just make a quick 3D model. You click here at the origin and just do it like this. Okay, now just see what we have done. So when you want to get out of the sketch mode, either you click right click and click on select, or you can just tick here and you will be out of the rectangle mode. So let's just look at this particular rectangle and see what we have done here. Now you can see there are these two sides are in black and these two sides are in blue, because these two sides are fixed at the origin, and if you click on this you can still change the sides. So it is not fixed. So if we'll have to fix these two sides also, you can do it by defining the dimensions. You click on the smart dimension, click here, and you just can drag here and click again, and you can enter your value. I am leaving it to the defaults, and you can see the value is also defined for this one, and we can also click here for the value and we can also fix this one. Now you can see everything is in black, and here you will see fully defined in below, and the fully defined means that our sketch is completely doesn't need more dimensions. It's already fixed, and these are the relations which I will cover later in tutorial. So the next part is let's just go into the 3D. To go into the 3D, there you have two options. Either you just get out of the sketch mode using this one. Okay, let's just do it. Now one more thing that about the feature manager tree, this particular handle, you can go choose what you want to see and what you don't. You can just keep it down and you can see the sketch, and if you want to go back, and you can just put it above. So this is how it's done. Now if you want to edit this sketch, you can just right click on it and again go to edit sketch, or you can just double click and okay, you can go to edit sketch and you can edit, and you can also add new sketches here. And let's just go into 3D and make our first 3D. Go to edit sketch, and you can also make 3D using exiting. Okay, let's just exit and go to extruded boards and select this particular our sketch, and you can say we are in a extrude mode. So you can set the dimensions using this particular handle, or you can set the values at what value will be the extrude. You can set your value here, and we are done with. So we have our first 3D model. Now if we want to make another sketch, and so we have two options for making sketches here. So either we can go again to the front, top and right plane, or you can make sketches on any particular side of this particular cuboid. So you just right click on it and click on the sketch. Now what you will be able to do, you will be able to sketch on this particular plane. Now if you make a circle on it, you can see there is a circle on this particular part. Now there is a circle, and you can simply go to extrude and select the circle. Now you can see we have a cylinder over this. So if we are going to make a sketch, then we will need a plane. So plane can be from these three, the front, top or right, or you can make a plane using any particular part. You can even make a something here. So this is it for this tutorial. In the next section I'll be covering all of these tools that you are seeing here. So hey guys, in this tutorial I'll be going through the sketches. So in the last tutorial I told you that if you want to make a sketch, then we need a plane. So I choose the front plane and just enter sketch mode here. So let's just go through these tools, and the first tool that you are seeing is line. So when you click on the little arrow, it will tell you multiple ways to draw a line. The first one is a line, the simple one. Here what you do, you get 2 points of a line, the first one and the second one, then you draw a line. So if when you complete a line, then still you can make a third point, then again it will draw a line between them, and then again a fourth one. So if you click back to the first point or any of these, then it will actually close the particular geometry. For example, if I click here, the geometry will be closed. Now we have made you can say a shape. For example, if you just want to make a single line, you click here and you just right click and click on select, and we are out of the line selection. And one other thing that you can do, you just click here when you are actually going for the drawing of line. You click here. Now you can draw again a line which we have seen here. Now if you want to draw an arc, what you do, you again go back to this one and you are switch to the arc mode. Now you can see we can draw an arc. So you can drop it anywhere. I am dropping here. So you can see I have made an arc. So with the help of line tool, you can make a line shape, and also you can make an arc. Let's go to the second type of line tool, that is a center line. So with the help of it, you just click at a point and you draw a center line. Center line is basically you can see it. First of all, it is in dotted lines are the construction lines which help you in making the sketches. They are not included in your sketch, so you don't you will not find them in your drawing sketches. These are just for the help purpose. And the next line is the midpoint line, which just requires the midpoint, and you just give it a length and it will be drawn. So these were our line tools. Just select all of them and press delete, and let's check our next one, that is the circle. So we can draw a circle in two ways. The first one is first you define a center. I will advise you always choose the origin for the center of your drawing while you are drawing sketches. So you click here and then you move your mouse and you can see the variation of radius. Now when you're done, you can just leave it here and your circle will be done. The next circle is actually a perimeter circle. In perimeter circle, you have to define 3 points. So with the help of 3 points, a circle is drawn. When you click for the first time, the first point of the circle is defined, and you click again, the second point is defined, which is here. And when you click on the third time, then your circle is actually made. So there are 2 ways of making circles. Let's go to rectangle. So there are actually 5 ways of drawing. 4 ways of rectangle and 1 parallelogram. So rectangles are simple. 2 corners, you just click one time, one corner will be made, and the second time the second corner. Next is center rectangle. The center is made, and then you, according to your need, you just leave it for the corner. Next is 3-point corner. You define 3 corners, click, and you're done. The last one, second last is 3-point center rectangle. First you define the center, then you're done. And the last one is actually a parallelogram. So I'm zooming out using our central mouse button key, and just you can see the angles. Now I have made my rectangle. Now I am zooming out again, and if you want to make an arc, there are 3 ways. The first is a center point arc. So at first you define the center point, then you define the radius, then you decide how much is the arc length do you want, and you're done. Okay, the next is a tangent arc. Okay, so if you want to draw a tangent arc, you will have to define 2 points out of sketch. For example, I choose this one and I can choose this one, and it is made, and I can do it anywhere. For example, I can make a here. Now the next one is 3-point arc. It's like a circle, like 3-point circle. You just pick it here and you just give it. Now we have a 3-point arc. Next is a slot. For making slots, we have multiple options. I will cover just single one for the straight tall slot. You click here and you just come here. First you define the axis of the slot and you then just move it according to your needs. And the next is for the polygons. If you want to make a polygon, you can see here I have making a hexagon. Now if you want to increase the number of sides of this particular hexagon, you can choose here. You can change the number of sides from here, whatever the number of sides you want, and you can change the dimension. X and Y present the position. You can see I am changing the position of it. You can send the radius from here. You can change the angle. So various options are there. Now the ellipse is left here. If you want to draw ellipse, let's see how many ways. So you can draw ellipse, partial ellipse, parabola and conics. I will show you just the ellipse. So just click on ellipse and click, and you can make an ellipse. So I will recommend you just do a random practice and you will learn a lot how to draw shapes, because in the end sketching is the first step for any 3D model. Next is for making curves. Though the first one is a spline. I click here at a particular point, I choose the next point, I choose the next point. So it will keep on making a curve which passes through these points. When you're done, just right click and select. Then I have a sketch. I can change the shape according to my need, whatever I want. Now next is just a point. If you want to put a point somewhere in a space, and you can just do it. Texts I will cover later. Okay, so we are basically done here. Now one of the questions that will come into your mind, that these look like a random shapes. What if you have to give dimensions to them? So for giving dimension, you just click on smart dimensions, or you can decide basically, like if you want to give horizontal dimension, which is this one, you can select horizontal dimension here and you can give it. Then click again and it will ask for the value. Now you put your value over here and press enter. I am leaving it to default. Now instead of doing horizontal, vertical and all of these stuff, you can just go for the smart dimension. It will automatically pick up. For example, I can click here and change the radius of it. I can increase it or decrease it, whatever I want, and then I just click on it. So you can choose the dimensions. So when you apply a dimension to a particular mode, then you can also change its position. You click on the dimension, you just drag it wherever you want, where you want it to be comfortable, and this is how you do. Now the next thing is, okay, for the dimensions part, basically we are done. Next thing is that the construction lines, and this is pretty important. Now we have drawn this particular rectangle, and you can see that we have these dotted lines, and these 4 are not actually dotted, these are solid lines. So what happens is that our main sketch, which will be visible, are in solid, and the construction sketches are those sketches which are just made for the help. For example, if I want to make something like this, for example, and I have to remove this because so what you do, just click on it and select for construction, and it will be gone, and your whole shape will be this outer section. So this is what we do. So if we can also make construction lines, you make a line and you just select for construction. And in the initially that we have discussed, in this case center line, it actually draws the construction line. These are all the construction lines. Okay, so we are done here with the sketching part. Next is the trim part. If you want to remove a certain part of any sketch, so what do we do? So let's just delete all of this and let's make something which is appropriate. So I will just choose the line tool and I will keep drawing a very simple shape. Okay, now yes, so you can see I just drawn a shape. Basically I don't know what it is, but it is something. So next task is I want to trim, for example, okay, let's do something that we can trim. Yes, let's just make some random lines here and okay, just pick it here, make it here, like something like that. And what if I want to draw a line through on this line and make it something like that? Okay, so you can see a lot of random stuff is going on and I want to delete, for example, 1 2 3, these 3 lines I want to delete. Now you can just go to trim entities. You can choose, the best one is actually the power trim. What you can do, you just have click and you can see a shape is made. So wherever it will pass, the particular shape will get deleted. So if I pass it through here, it will get deleted. It's also getting deleted, and this is how it works. So if you want to delete a particular shape, a part of any sketch, you can go for the power trim. Power trim is basically you just pass it through and it will delete that particular selection of your sketch. Pressing Ctrl Z for the undo. Now just another thing is there are multiple modes for the corner trim events and you can go for all of them. Another is a trim to closest. So it just works on it wherever we will click and the closest shape will be get deleted, and this is how it works. So trim to closest, and you can see another option, keep trimmed entities as a construction geometry. So if you want to keep this particular shape, the inside, you can just click here and you can see it is here as a construction part. So this is pretty much useful. So trimmed entities is basically used to delete the extra shapes that we make while making one. Now converted entities, these two we will discuss on when we will be making our 3D models. Now after discussing these and these, next comes the mirror entities. So for example, I have made this shape and I want a mirror of it right down here. So I make another line here in the center. So I made a line and I want a mirror of this on this side. So what we do, we just click on the blank space, go to mirror entities. Now you can see there are two options. The first one says entities to mirror. So what are the things that you want to copy? You can just click here and drag and select all of your parts. Okay, now mirror about is like you select the particular line through which you want to copy and click. Now you can see there is a mirror of it. Now you can actually decide whether you want to make a copy of it or you want to move it. If I just click remove it, then you will have just this one. And pressing Ctrl Z and I'm go back to the original one. And if I just want, okay, if I just want a copy of it along with this one, so I can have both. Okay, I did just a mistake here. I want to mirror about line 67. Okay, and you press enter and we are here. Now, okay, the mirroring that we know right now, press Ctrl Z again. Now, next thing I'm gonna teach you is the linear sketch pattern. If you want to make this shape like 10 times, so there are two ways. The first one is you make it 10 times manually. Otherwise, there is a way that you can just pattern it. It will take few seconds and it will be done. So you can go for the axes. You can see the x-axis is along this side and y-axis is on upward side. So you decide how many copies do you want. Now first you put the values, entities to pattern, what are the things that you want to copy. So you just select it. So when you're done selecting, You can change the distance. At what distance do you want to see the copies? Here you can decide how many copies do you want to see, and so on. For example, we wanted 10, you just put here 10 and it's done. And you can also make it at a particular angle, and you can see it is rotating at an angle, but I want it at a 0. So okay, and we are at a 0. You can put your values here. Now if you want also to have the copies along the y-axis, you can just change your values here. Okay, we'll have to change the distance, and you can see we have it right now. You can just choose the quantities. Now this is how you make shapes. You can make hundreds of them without wasting any time. So this is all about the sketches. Okay, so this is about the actually linear sketch pattern, and I'm not gonna save it, so I will just go back here. Okay, so the next thing that we are going to discuss is the circular pattern. What if we want this particular drawing in circular sketches form? So what you do, you just go to the entities pattern, you select your parts, and you just keep selecting it. Now when you're done selecting, and you can remove a point, just right click and delete. For example, if I want to make the pattern around this particular point, then you just click on it, and the radius of that particular circle will be equal to the difference between the distance between this point and the sketch. Okay, so it will be actually the minimum distance. Now you can choose how many parts do you want. You can see the number of parts are changing. You can also, actually we cannot change the distance here because it is actually fixed here. Now it's done. Yes, now you can change the angle if you want a little bit of angle, right? So this is about it. So we are done with the circular pattern, and the next thing is you can see that our sketch is actually fixed at the origin, this particular point. Now if you want to move it, what we can do, you can just select your sketch, go to the move entities, and you can choose from and to first of all. So now you can see we are moving it, but I don't use it. Actually this becomes pretty much hectic for me. I choose mostly the XY, and I just select it and I just change the shape what I want. Now if you look at it, you can see the shape of our drawing is changing, but there is something that we can do that the shape doesn't change, and you can see in the bottom that it is written underdefined. So our sketch is not defined, and let me just delete this line and we will define the sketch. So you can see these two lines are in black and these are in I will also delete these, this one also, and I will add a line here. Okay, so you can see we have a closed shape now, but still when you look here, these two are in black and these are in blue. So what happens there, these two lines are actually fixed about origin, but this is not fixed, so I can still change these value. So we'll have to define the sketch so that it remains same. So there are two ways to doing this, and we follow both of them. The first is actually assigning the dimensions. So more the dimensions we assign, better we get. So if we define the dimensions for all of the sides, for example this one also, you can do it the vertical distance or the horizontal distance or whatever you want, you can do it. Just if you decide dimensions for all of them, I am just giving the default. Okay, so right now you can see that there are still it is in blue line, so we will try to just move the diagram, and you can see dimensions are still the dimension that we have defined, like 0.24, 0.09, 0.15, it is still there, but still the shape is changing. Now what you see that these two dimensions are not defined. So what you can do, you can just go over there and define these dimensions also. Now you can just give them a dimensions, and now we are in black because all of the dimensions are defined and it says fully defined. Now there are a few things which you should know. A must is that you can also define the angular dimensions. To do that, you select two lines and you can see you can define the angular dimensions. Now you can just change it, or I can change it like this and press enter, and then you can see it is changed. And another thing, so this is all with the dimensions, so you can put a lot of dimensions here. And the next thing which is very important is, let me just remove this dimension and let me tell you an easy way to do this. So sometimes we work with a large dimensions, large sketches, and we have to apply make them fully defined. So it's not a good practice to just apply dimension. There are some obvious relations that we can provide. For example, in our sketch, these two lines have to be equal, and this particular and this particular and has to be equal also, and this section and this section, these are the collinear lines, they are in the same lines. This is perpendicular, so we can apply some relations on it. To do that, click on add relation, and for example, if I want to make this line and this line equal, I select these two and it shows all the relations that we can apply. For example, we cannot apply it horizontal because it is a vertical line, so we can apply it the vertical. And if you see, there is a vertical hash line, so the symbol of vertical is this, a vertical line that is already applied here. So we can apply parallel, so these two are parallel, and we can also make them equal. So what happens when we do the equal thing is, even if we apply a dimension to a single line, other line will already become equal to this one. So this is what happens if you have 5 particular lines, a circle or anything, you apply a particular relation on it, and you apply dimension on one thing, and then everywhere it will be applied. For example, let me just make it more clear to you. If yes, let's draw a circle. So for example, I have like these circles. Okay, I want to give dimensions to all of them, the radius dimension. So one of the ways is I just go old school and provide dimensions to all of them, and I make everyone like a 0.24. If I want, I just type in and I can keep on doing it. It will take a lot of time, but this is also a way. But a smarter way to do that is just you apply dimensions to one, that is 0.24. You go to add relation, and so you select all of your circles. Just click here, click here, click here, and you just click on equal, and you can see everything is made same. So relations gave us they gave us speed. You can work in much better way. You can always work with dimensions, but dimensions take time. So let's add few more relations, and select this line, select this line. These lines are collinear. These are going to be collinear. Just done with it. So this is a symbol of a collinear. You can, and if you want to delete a particular relation from a line, for example, if I want to delete this collinear, what you can do, you can just click on this little tiny icon, you can click on delete, it is getting deleted. And another way is to delete is just select the line, go to display, or just click here, and you can see the collinear is visible here. So you just click on delete here and it will be get deleted. So I would recommend you to apply as much as possible relations, because relations make your work easy and you can get away with lesser dimensions. And when your sketches doesn't need any dimension or relation, and there will be written a fully defined. So I'll be doing a quick sketch exercise in next section, so you will get all of the things which I am saying. See you in the next section. So hello, let's just go through one example that will be this one. Okay, so we'll be making this one, and yeah, this range structure drawing. So let's just start with a very fundamental thing, that when we start to sketch any drawing, then we have to define the origin point, like where we are going to fix our sketch, which point. So we can fix the center of this larger circle as the origin, or we can set the center of this particular line and this one at the origin, or we can set this circle center at the origin. So let's just see what I have done. So first of all, you change the units. Units in this case are in millimeters. So first of all, I draw a line in the front plane. I go to front plane. Okay, now you can see it's in a little bit different mode. Now you can just go, yes, now we are here. You go to here and draw a line. The length of the line is actually there's a tip I want to give you whenever you are drawing any shape or anything. So there's a one fact that you will not draw the line close to the 100 millimeters, but you try to keep it at the closest value possible. So I am keeping it around the 99, and the yellow shine is showing that it's a horizontal line, and that's okay. So I just leave it here. I just go to give the dimension. So another thing is that as long you keep putting the dimension and everything along with the sketching. Now this line, okay, just get out of the smart dimension, and this line is for the construction. This is not the part of the sketch. Now next part is I am going to draw 4 circles here. So the diameter of the outer circle is 32, so it is around 16. So I will draw a circle closer to that. Then the same one, it is of 13. I will leave it to around 13. Yes. Next is 15 and 9. Okay, here it is 15. The next one is 9, close to that, and just apply the dimensions. Actually, in the end, what is expected of any sketch, that it is fully defined. That you can see it is said underdefined, and fully defined comes in when you actually make all the dimension and relations. So the outer one is 32 and inner one is actually 13 to 26. It's 26. Yes. Now apply here the dimensions. So the dimension of this outer one is 30. Okay, the inner one is 18. Okay, so we're done. Now you can see everything is in black. There's no blue color. It means we are good till now. It is fully defined. Now let's just go and do our job. What's next? So next thing is let's just go to drawing, and next we are going to draw this reference line. So I'm going to draw a line here and make it random line. You don't have to give it a length because it is actually going to be a construction line. So it's a construction line, it's defined. Now we do the sketches. There is a parallel line. We get out of the line, then there is another parallel line which start from the inner circle and get end on the outer circle. Now let's just go to add relation. Now you see these two lines has to be parallel. They're not supposed to be okay, they are parallel. They're also equal. Okay, so we're done with this part, these lines. Okay, so let's just add dimensions here. The angle between this line and this is 17 degree. If you look at the diagram, it is 17 degree, and the distance between the line is the 17. So you apply that the 17, it is also done. Another thing is that the distance between this and point and the line will be half of the 17, and it says the dimension is driven because these two lengths are equal. But let me get out of this. So if the distance length of this line and this line is equal and at the same angle, then obviously the distance will be half of the 17. That's what we were going to do. So whenever you see something like the driven dimension, it means it is already defined. So it says fully defined. Now now we remove the entities that we don't need. So I selected power trim, just click and drag. It is removed. We need to remove this inner one also, and we need to remove this one also, and this one. We don't remove these construction lines because they are deriving this sketch. If you remove them, then it will fail again. Now it's here. Now you can see the dimension has been deleted, so again apply the dimension of this, which is absolutely 39, press enter. So we are all black here, it means it's done. Now let's just come back to this one, and we're gonna do the same thing here. The first will be to draw a reference line right down here. So the reference line will start somewhere around here. Make it construction. As soon as you come here, you just do it. It is construction line right now, and then you draw the lines which goes through it. It goes to the outer one. Okay, then you do the another line which is okay, actually it is slipping on this plane because we have not defined the location of the point, but we can do it later. I just made the second line. Let's just apply relation between this line and this line. So both are supposed to be equal and both are supposed to be the parallel. Now I apply the angle between these. Now you can see in the diagram the angle is actually this one. So you can apply inner angles or the outer angles. So outer angle is given, which is 163. Press enter and it's done. Now you can see we still have it blue colored. It means and you can say below it's underdefined. So something is left, and that is the distance between these two, which is 13. Just apply it and it's fully defined. So we are done. Let's just trim our entities which we don't need. We don't need this, we don't need this, we don't need this, and this. Okay, we are still fully defined and we are done. Now the time has come that we make the central part. So for the central part you can do two things. Actually, you can make a center rectangle at the center, and then you draw the these arcs, or otherwise you can draw a simple line and draw the arcs. So I am choosing the difficult and longer process because I want you guys to learn more. So let's just start drawing here, lines here. So when you can see here, when I try to find the first point, it is already showing a dotted line. So it is actually helping us to draw the line from the same vertical line. So yes, so we have, so it is a horizontal line. Now let's draw our arcs here. So our arcs has to be the one point is here and another one is here, and it's a 3-point arc, and the midpoint I select randomly here. I will define the final values later. So do it randomly. Okay, now you can see what we have to do. Let's just apply some relations. So the relation, okay, first apply relations in these arcs. So these arcs has to be equal curve length, and okay, it's fine, just that equal curve length for this one also. This also supposed to have equal curve length. Just press equal and it is horizontal. Okay, it will be parallel, obvious. Now the next thing is we'll have to define the tangent. So this particular arc and this circular, both of them are in tangent. Same for this and this. This is also tangent, and here you can just go for this one also. Just clear section, go for this tangent, and this one also. Okay, we are done there. Okay, Now the next thing, we're still in blue here because we have some dimensions here. So the distance here is supposed to be 11 here. Just enter it. Now we know another dimension, that the distance between this line and this line will be absolutely 11 by half. 11 by 2 actually. Now we see that still we have few problems here. Now what you can do, what's left here is this arc is also tangential to this line. So you select both of these, select tangent, and it looks fixed. Go for this one, tangent. This is also fixed. Now you go for this one, tangent, and lastly this one, and we come out of it, and there is still something left. And if you want to know what's left right now, the thing which is left is that this point can still move. We'll have to fix this point, so we'll have to find a dimension which we actually left here. So that is the dimension of the arcs. So the dimension of this arc is 47. You put it. Now it has turned black, and the last one is the dimension of this, so that is 23. And we are done here. You can see all black, fully defined. So whenever you are making any sketch, try to make it fully defined. That is the first target. And if you want to extrude it, which is not a part of the exercise, but let's do it. Go to power trim, remove it, because extrude can be done in a closed surface. You can also do to that surface, but I will cover that later. So you can see it is done, fully defined. Now let's just go to extrude base, both actually, and it's done. Choose your value, press enter, and we have made it. It looks cool, right? So in the next section, I'll be covering these features, all kind of revolve and other features. So yeah. Okay, so welcome back everyone, and in this tutorial I will be covering these features, all of these guys, and a few things which we have left in Sketch, like convert entities and offset entities. Okay, and we will also be going to few more things such as reference plane. So let's just first cover the extrude boss feature. So this is the last sketch which we have made in the last section. So let's just go and extrude it. Now let's look at all of the options. Okay, let's just decrease the value here, get like 20 or something. Okay, so just wait. Yes, now the first part is where you define that what should be the extrude length. So when you put blind here, so either you provide a normal direction in the direction which extrude will take place, or it will just extrude in the normal direction of the this particular surface, or you can provide a direction vector here. So I choose the 20 mm. This is where you can change the distance. So, and the draft, what it does, it provides an angle, so you can see it. If you just look at it, as I increase the angle, you can see it gets thinner. You can provide, if the draft is outward or inward, you can see what it does. So this is draft feature. Next is direction 2. So if you want to do the same in the, if you also extrude in the other direction, let's take it mind 40. So you can see, and if I make it draft inward, which is not possible actually, so I just decrease the value here. So you can see this is what it does. So this is the direction 2, and this is direction 1. Now few other features include the thin feature. In thin feature, okay, I will cover just after it. So this is what happens in this case, right? Up to vertex, up to surface, these are all features I will cover in the exercise, which I will do just after this particular tools discussion. Now let's discuss the feature, another feature, which is thin feature. So you can see Let me just decrease it to like 50. So you can see it's a hollow structure. What it does, it takes the particular curve and it took outside curve length of 1 mm and it extruded it, and that it is. And the curve is when we click on cap ends, it actually closes the curve, otherwise it's a hollow, you can see. And when we we can see from here to the second end, when we click on it, it becomes a closed surface, but it remains a hollow one. So this is what happens when we select this. Next feature is revolve, because this actually does what it says. So to do that, I have to edit the sketch. For example, I go to the same sketch. Okay, let's just make a new one. So I go to front plane again and make a sketch. Let's just enter the front plane, make a line around which revolution will take place. So I draw a random line here and just am done. I'm not giving any dimension or everything. You can give it if you want. So now let's go to revolve, take this, select this one, select contour, select sketch one. Okay, what we've done here wrong, we selected this line, select this, yes, we're done here. Now you can see if I select the sketch, it actually revolutes around this line. You can see if I just turn it to like 10 degree, you can see it's just in a 10 degree angle, and if I increase it, it slowly starts to revolve around it. You can see this is really beautiful. You can see. So for example, I just want it to be like in a 150 degree. I apply it, you can just exit, and you can see we are done here. It looks really cool. And other settings which are here include the direction up to vertex, up to surface, and other stuff which I will cover in exercise. So this is about the revolve. You select the contour and you select the axis of revolution, and you're done. What we're gonna do next is go for the swept boss, and it requires two drawings. The first is a profile and the next is the path. So for the profile, let's make a random shape right down here, and we go to sketch and let's select the front plane. That will be this one, and just make a random shape here, which let's just make a random shape which just passes through here. So I just made a random shape here, and now next thing that we need is a path that it will follow. I go to top plane again. Now I make a random shape, so you can see it is perpendicular to this one. So let's just go to the top and make some random shape. Okay, I guess that will work. So we have a path, we have a profile, we take an exit. Let's just go to swept boss, select sketch profile, which is this one, and the path is automatically selected. And you can see now we have a solid surface. In solid surface, this was the profile that we use, and inner one is actually the path. So it is really useful if you are making a complicated design, and you can see here. Now let's just look at other options that we could have done. So if you have to actually make a circular profile, you don't have to make, you just can go select the circular profile and select the path, and you can set the diameter from here. So you can make pipes kind of structure easily. And other options are like you can add some twist here, add some twist values. Wait, yes, so you can also add twist values from here, like you can see there are some variations in twist. You can see it is rotating here as I'm changing the values. So make it like a 50 or 46 degree. So it has changed quite a bit, and you can do a lot of changes. Like you can keep the normal constant. Like for example, what means normal constant is that normal will remain like this. Let me just apply it. So if I do that, most probably I will hit error, because actually the here profile and here the paths are not getting, they are intersecting each other. So just apply follow path. So you can put some twist values from here, and that's it. So this is from the Swift boss, and this is how you can have a fun with this one. So yeah, so this one is done. Now next part is go for the lofted boss and the boundary boss. So we'll follow other drawings for that. So let's just understand two concepts which we actually left there and from sketch. The first is the convert entities. So for example, if you want to extrude this particular surface, so what you can do is just click on this, press edit sketch. Okay, so you can, okay, not here, you will have to click sketch here, and if you want to import this particular surface as a sketch, you can just click on convert entities. Now you can see we have this black lined surface, and if you wish to have a smaller one or a bigger one, then you just click on the offset entities and select this sketch. Now you can see we have option, so you can get bigger or smaller one, whatever you want. So we have covered this sketch entities. Now let's just come back to this lofted pose and this boundary pose. So the basic requirement for both of them is that we need two sketches for them. So we will be learning one more thing before that, that is the creating planes. So we will have to make another sketch which will be in other plane. So let's learn how to make a different plane. So different plane can be made using references. So for example, one of the reference that you can use is you choose the front plane and you choose the distance, like at how much distance do you want that plane. So you can see, so we can choose a distance. For example, like I choose 0.3, right, and I just click on it. Now I want to draw on this, so just right click and click sketch. So I am in this particular plane. Let's understand, let's make a big sketch here of this, a big one, hexagon. Okay, now one more thing, just get out of it. You can you can even edit the plane. Let's click on the edit feature and increase the distance. I want it to be around, like, increase it 0.5. Okay, so we have two sketches here. Now we can go for the lofted boss. So just click on here, and you will have to add surfaces here. So you can do it easily by multiple steps. For example, you can just select one, click on one and select another, and you have a surface. You have the lofted solid, actually it's a solid. So you can mess with these pivot points. You can see the shape changes. According to that, you can just keep on changing it. So this is how the lofted works. Another way to do this is right click, select selection manager. So you can select the whole sketch, close surface all at once, or you can if the sketch is actually open loop, you can use this one, or you can use this selection manager for every single selection, or you can go for this particular surface selection. You just click here and enter, and again just come here and select it, and you're done. You can mesh with this one. Okay, now you can also okay, the next thing is start and end constraint. Okay, let's just look into it. So start, you can add, for example, if I select normal to profile, right, So this is the first profile. You can select that how much you can set the value that for how much length it will be normal to the original profile. So if I increase the distance, you can say that in this area the projection is actually normal to this particular surface, and you can choose same thing from there. Now for example, if I choose none from here and let's just apply from here, if I do the normal to profile, and you can see the same thing is happening, and you can see it's increasing. So the normal profile influence is increasing as soon as I increase this one. And the next thing is a guide curve. Guide curve is used as a way that we allow the path in swept pose. For example, I'm just going to make a quick path for this one. So let's just make it, let's see how it looks. So let's delete it and make a path. So we will have to again make a plane. So we will have to make a plane which actually passes through this point, and this point. So we can make a plane from 3 points. So press enter and we have a plane, and just enter it. Now let's design our path. So our path will be, so just enter the spline and make a random. So the path will be like something like this. It closes here. Okay, so this is our path. I want to reach from this profile to this profile, and this will be the path. So this is what I'm following, and I am getting out of it and just go to the lofted pose, select the sketches. You can just select it this way, just clicking on it. Okay, it is not working now, so that's why there are other features. This one is working. Okay, go to selection manager. This one is also selected. Now choose the guide path. I chose the guide path, and you can see what's happening here. So it has actually done the loft thing, but along that particular guide path which we have designed. So this is what happens. And one more thing is that if you click here in any feature, then you will see all the sketches on which this particular feature is derived. So we are done with the lofted boss, and I will delete it for now. Next feature is here we don't need this path, so I'm hiding it. You can also hide your things, just right click and I can show it, or I can hide it. Now next feature is the boundary boss feature. So boundary boss feature actually allows you to create solid in 2 directions, but there is a thing that you cannot make the guide path in boundary. For example, and there is also one more difference, that is you can also apply the thickness feature here, that is thin feature. For example, if let me just select these guys. Okay, both of these are selected right now. Let me just change some pivot values. It looks much better. I mean, yeah, it looks cool. Now let's just apply thin feature, and you will see that it will be like a thickness will be applied to it, and you just click on it, and you can select the thickness from here and just click on it and wait, and now you can see it's a hollow structure, but it looks really cool, right? Now this is what happened in boundary boss. You can apply thickness also here. Okay, so let's just go back to our let's go to other features, that is extrude cut and these kind of stuff. And I'm going back to this one. It looks complicated, but I want to work with this one. So next thing, that is the extrude cut. So extrude cut is same. I mean, in extrude boss we are actually adding a third dimension in any profile plane. So in extrude cut we remove the solid from any surface. So for example, if I want to remove some surface or some solid from here, so let's just draw a sketch here, right click and sketch. So I want to remove it in the shape of a rectangle, so just click anywhere and I just left it here, and you can exit the sketch or you can just go directly on extrude cut. Now you can see, if I just click here, you can see the value is 0.556 meter. If I just tick here, things along this particular profile are gone. This is also deleted, this is also deleted. Now what if I want to just remove this one? You can just easily decrease the distance, only this part is removed, this remains safe. And there are other features. If you click up to next, then delete, then extrude cut is only done till the next surface. You can see it, and when you're done it, only this surface is removed. And there are a few more features like up to vertex. I can show the up to vertex feature, so the distance can be selected by any vertex. Like, yes, you can see I clicked on the vertex and the distance is selected. I can also select the features like up to surface, so removal is done till here. And yeah, pretty much it. So through all, if you do through all, it removes everything that comes in its path. Through all both means it removes everything on the both sides. Okay, so cut extrude is complete. I'm gonna delete it. Next feature is hole wizard. So if you want to make a hole, then you can follow it. So holes can also be done by the extrude cut, but with the help of hole wizard you can create some standard holes. For example, you can see there is a tapered hole and it does not crosses it, so you can do a lot of things. For example, let's just create a tapered hole here, and I have selected the tapered hole in say inch. You choose everything, size you can select, I want M4. Okay, now the position, you click on the position, it will ask you to draw a 3D sketch. So I want the hole to be at the top of the surface. I go here and you can see the yellow thing, I just dropped it. You can make a multiple holes, you just click anywhere, it will drop holes right down there, and just click OK. You can see I have holes here at the 5 places. I have holes. So this makes the whole process pretty much easy, that you can do anything at any place. Okay, the hole is done. The next feature that we are going to discuss is the revolve cut. Okay, now the revolve cut it's pretty much same. Now let's just do a revolve cut. So I will choose a plane along which I will cut. I choose top plane, I go to it, and I make a surface here. Okay, yes, let's just make something. Let's just make a random shape. I like playing with the random shape. So yes, this is the random shape, and with the help of it I am gonna cut this thing. Now I will be deciding the line of axis, so I would rather make it in a new plane. So again I will go to this plane and I will draw a line. Okay, this is the line and I'm done. Now this I will cut this solid body using this particular shape along this axis. Extrude cut, revolved cut, sorry. Okay, now you can see it worked. So yes, if I just close it down, you can see it has cut everything that has come along its revolution, and I can just control the revolution in angles. Whatever, you reduce the angles, make it like a 145. Yes, now if I exit it, you can see the cut. It just cut this particular part. So this is it. This is how you can cut using a revolved. Okay, the next thing is swept cut. So the swept cut is pretty much simple. You make a surface anywhere and you can cut using the sweep path. So just one example, I'm gonna show you that. So yes, so let me delete these sketches. Just wall. Okay, I'm gonna select plane 4 and I will draw a random thing. So then a random, actually I choose random figures because that means it can work with anything. So I'm just gonna make a spline here, a random spline on that plane, and I just leave it slack. Go to, okay, I'm exiting the sketch, go to feature and go to swept cut. So I'm just going for the circular profile. You can try with the sketch one. Now you can see from wherever this path has passed, there is a circular profile which has been made. Let me increase the value. And in swept cut, there will be subtraction. So from this solid, this swept part will be subtracted, and you can see it. So wherever the path has passed, there is a subtraction is been done. So this is you can say a advanced level of cutting which has been done by swept cut, but it is done. So swept cut is done. Next is the next is a lofted cut and boundary cut. So we will complete it very fast. So we will require 2 surfaces for that. Let's just edit this one. I'm gonna remove this guide curve. Okay, now we are going to see the lofted cut and the boundary cut. So both are basically the same. In lofted cut you can apply the guide curve, and you cannot apply the thickness. Thickness can be applied in the boundary cut, which is using the thin feature. So let's just apply a cut using this loft cut. So I'm going to make a plane, reference plane from, okay, which plane? Yeah, okay, I'm gonna make from a top plane. It works 0.50. Yes. So I will make a plane here. Click on the plane and sketch. Now I will make a small circle here. Just, and if you want to go perpendicular to it, you can try this. Okay, this is different. Okay, just draw it. You just leave it here, and we make another surface. So we make another plane with the help of it. Flip offset means you change the direction, and yes, increase the distance. So I'm choosing sketch also on it because I need 2 sketches. So I will choose a small sketch here. Like, okay, let's make ellipse. Okay, we have 2 shapes, and we will draw a lofted cut. We will make a lofted cut using both of these. So just go to, leave it here, and go to lofted cut. You just choose the plane surfaces, this one and this our ellipse, and you can see a subtraction will be done between this profile and this one. Just when you click OK, and you can see a hole has been made. So this is how a boundary cut is also done. Let's just move next to these features. So we have covered all of these both the addition and the subtraction. Now some extra features. So let's just go ahead with our next uh, tool, that is a fillet. So fillet, if you look at the icon, you can actually realize that it is used for smoothing out the edges. So actually in real life, if you are working on any product design or industrial design project, then we don't want any edges. So our purpose is to remove the edges, so we can do it by choosing the fillet. So there are two ways that you can do it, by choosing manual or fillet expert. So basically I prefer the fillet expert, because in manual you have a lot of selection that you can do. It gives diversity in selections, but fillet expert does your job very easy. So in items to fillet, you can select the faces, edges. So I select the edge here. So you can see fillet has been applied. The radius of the fillet is 0.002 meter. Now I can just keep on selecting these edges and it can work. Now there is one more thing. If I want to apply the all at once, if I want to apply the fillet to all of these edges all at once, then I can just click on the surface. So when you click on the surface, all the attached edges get fillet. For example, if I just click here, you can say that all the edges gets their fillet. So there are a lot of options that you get in when you go to manual. You can go for like a variable fillet, size of fillet, and you can also go for the full round fillet. So these are a lot of options that you can explore. And next is a chamfer. So chamfer is basically like, I mean, you should see this. Yes, it just applies an angle for the cut, and yeah, this is what it does. And you can change the angle from here. And there are multiple ways to define the this chamfer. For example, here angle and the distance is used, and you can use distance only. Here symmetric is selected. If you select the asymmetric, and you can change the values here with which you want, so you can see what's happening here. Or you can you know, there are multiple options that you can explore yourself. And the next is the linear pattern. I have discussed it in the last tutorial of sketches when I discussed linear sketch pattern. So what it does, it makes a copy of whatever we are doing. So for example, if I want to create multiple copy of this object, this body, I just select the linear pattern and I go to bodies and I select this. Now you have to select the direction. So I set this edge as a direction, and you can see with this the quantity is 5 and the distance between each is 0.13. Now I can increase the distance, and you can see it varies. Now I can do same in direction 2 by, for example, if I select this as direction 2, and I got 5 cross 5, that is 25 quantities. You can not only just copy the bodies, you can also copy the features. For example, let me do a quick sketch here. And for example, if I make a hole here, so I am going to make a hole and I select up to next. So when I click up to next, then it will complete the hole till the next surface. And so if I want to make like a 5 holes here, so one of the ways is you make 5 sketches, then you can apply the whole thing. Otherwise you can just go to linear pattern, select the features and select this hole, and now you just select your direction and decrease the distance as per the need, and you will see, and just click here. You can see the hole has been applied here. Now you can do the same if you just want to apply that the same thing in other direction, and it makes the whole work pretty easy actually. Just select this direction and just keep on decreasing the distance, and yes, and increase the values also. Now I just make it like a 0.02 and decrease the quantities and click OK, and you can see I have a multiple hole body here. Next is and if you apply fillet here, that will be pretty interesting. And go to fillet expert, and just if you click on then the fillets will be applied to these holes also. That will take some time, and you can see how pretty it works. Just click here and you can see the fillet has been applied to the whole body, even all the edges actually. Now okay, now next thing is the circular pattern. So circular pattern, I am choosing just an easier way to explain this, and for pattern I'm selecting the body here, and for the edge I'm just selecting this one. So this is the axis, so it just rotates around it, and if you want it in a particular big I mean in a larger circle, you can draw a sketch and then apply it. So I have 3 models here. Now next thing is here is the mirror. Now if you want to make a mirror of this, I want 6 systems, so I will need a plane. So let's make a plane which we will use as a mirror. So okay, I will choose this, and distance 0.05 is automatically applied, and I'm okay with it. Now what I do, I go to linear and select mirror. Mirror face is applied here and the features are applied here, but what I'm doing is applying the bodies. So you can select the bodies here and just keep on selecting whatever you want, then click here. Now you can see we have multiple bodies and they are in pattern mirror. Now others are obviously I have discussed some of them in last tutorial of sketch, like curve driven, and for this I am keeping just down here. Now let's just come back to it. Now next feature which I'm going to discuss is pretty much important and pretty much useful, that is shell. So shell makes you just say it, what it does. I will apply something value, like a smaller value, something like that, and so preview is on. Now when I apply this, you can see you can cut out the material, and according to here I have selected this top surface. So when I select the top surface, then that face will be deleted, and a shell will be made, and the thickness of the shell will be equal to this one. For example, I can click the cell outward, then all the inner part will be deleted and external thickness will be provided. So you can see now this is what a cell does. You can apply it anywhere basically. So I will take it upward here. Now next feature, let's look at the intersect feature. So for example, if I have I draw up something here, and I take a random shape here and extrude it up to some distance. Now there's a feature which I haven't discussed with you yet, that is merge results. So what happens in merge results is that if you click on it and then select OK, then both of these become a single body system. But if you want them to be like different, then what you do is just unclick this and then click OK, and you can see both of them are different. So it becomes so if you are going for the rendering, for applying materials in rendering softwares like Keyshot, then I would tell you that always untick this, so it becomes a lot easier. So you have to take the decision early on in modeling that do you want a single body system or a multiple. So you keep on you can select that. Now to explain the intersect, actually I will need a different one. For example, I am deleting the sketch. I will be making a random sketch for better understanding. I just take this and I make a random sketch here. Okay, now I will extrude it. I will also extrude in direction 2 a little bit. Okay, now you can see I have two bodies here, And for example, if I untick here the muzzle, now I can use the intersect feature. For example, if I want the part which is common to both of these bodies, for example common to this and the boss extrude 3, so I just click on intersect and I select the bodies which I want to research about. So I want for example, let's just search both, and you can see, so whatever you will click here, that part will be excluded. So you can see this is the reason 1 I want to exclude it, this is reason 3 I want this reason, and this is reason 2 I can also exclude it, and just take here. Now you can see I have a body. So intersect actually allows you to define any body from multiple selections. So this is what we did here. We had 3 things and we made a single one, a common area. You can also go for like I could have selected like these guys, and we got this. I did this cut with the help of a post extrude one. It was a cuboidal structure. Now it is also, let's delete this one. Now next I am covering the wrap. Now to explain the wrap, let me remove this one also. So I will need a plane, so let's make a reference plane from here. Okay, I will need actually a curved surface, so I will keep this one and I am deleting this. Okay, everything is deleted. So let's make a new sketch. I am making a splined surface here. So more random, much better. So I am just extruding it. Okay, let's just apply some height to this. Now for example, if I want to make a hole on it in a particular shape, so that's when we use a wrap feature. So you will understand much better if I show you the example. So for example, I choose the right plane and I go to the reference plane. I make a plane by applying some distance. I choose some distance right down here, and then I create a shape here. For example, if I have a shape and I want to apply extrude cut, right? I mean, just example is this. Yes. Now if I do extrude cut using this one, and let's do the extrude cut up to from I want it happened from this surface, and the blind length has to be like 0.1 meter. Now if you look at it, actually it is doing a pretty much good job, but wrap feature actually helps you to also do some different thing. We can also do cuts using the wrap feature, but in a different way. Now if you select this, in the first selection you select the sketch, in second selection you select the body. Now you can see a projection of this ellipse over this. Now you can do 3 things: emboss, deboss, or scribe. In case of emboss, actually a projection is done which will be outerward, so you will understand much better if I apply it. Now you can see the surface is actually embossed on this surface, so it is this particular shape is embossed on the surface. Now another thing is like if you select the deboss, it will actually subtract, do the opposite thing. So you can see this is inward. Now the next thing is just scribe feature. So scribe does nothing, it just you can say it projects the sketch on it and it's done. Now you can have do anything with it. Now if you can also access this sketch using, you can go to sketch, select 3D sketch. Now you can select this inward and convert entities. Now you have this spline and you can do anything with it. So we have discussed the almost all of these guys, and I will discuss draft in in the mold section. So we are done with the features. So we have covered the sketch and features, and in the next I would say that you should also go for the practice. Before practice, do not go to the other sections. And when this video ends, you will see 2 videos from my own channel where I have done some projects using all of the features which I have discussed till now. So you can go there and practice. Otherwise, just go ahead with the next section of the tutorial. So hello everyone, and welcome to the new section of our tutorial. In this tutorial I will be discussing about the assembly. So let's just start. So we will learn it by doing a project. So I'll be explaining tool and using them all together. So there is an assembly. You select the assembly. So when you select the assembly, it will ask for the parts which with you will do the assembly. So I select all of the parts which I will use. So it will ask you to place them. I am placing them wherever, at a random place. So I can just wait around here. So we just okay, right now the final product that we will do will something look like this. So we have all the parts. Now what we want to do, we want to assemble them into a single product. So these are our different product parts. Now assembly is very important because it gives you the whole product with and you can also define the constraints and everything. So let's just start with basics. So first of all, you can move your components from here or rotate. So let's just select move, and you can click on it and move anything that you want, but I cannot move this one. So what I can do is just right click here and click here float. Okay, it's let me check. Okay, it's already moving. Now anything that doesn't move, you can just set the option. So if you want to fix this one, you just right click and fix, so it will not move. Now let's just work according to this image. So in this image you can see these two are aligned. Their center is same, so they has to be concentric and they are touching each other. So so we can start from there. So yes, so let's start. So first of all, I will do in sketches we have discussed the relations, right, to define the relationship between the different sketches and also to limit them. So in assembly we define the mates for the same purpose, to give them a limitation in their movement. So for example, there is a concentric mate. So for the concentric mate you have to select a cylindrical surface or a circular edge. So I am selecting the surface. I am also selecting the surface here. So as soon as I do that, you can see both are aligned in the same you can say same. Now they have the same axis of center. So you can also lock the rotation, otherwise just click out of it. Now when you go to move here, you cannot, it will always stay in this axis. It can rotate, even it can move along, but it will their axis of center will remain same. So this is what is happening. Now they both are connected in a way that this side has to be the other side. The planar sides are touching each other. So we can achieve it easily by using mate. Go to mate and select here coincident, this surface and this surface. Now both of them are coincident, but we do not want it this way. So you can just click here, it will opposite it. Now this is what I want. You just select OK. Now if you try to move it, it will not move because this is in the center. Their center is same and it is coincident to this one. Now this system is fixed. Now there are different mates. You can see the parallel mate, perpendicular, tangent even. So let me just tell you about other mates. So the next thing that we have to do is to put this key in this let's call it lock. So we have to put this key in this lock. So we can try coincident easily, it can work. Now there is I think I should go along with okay, let's try something. I have another in advanced mates. I will use one advanced mate here. The advanced mate is the width, so I can use width here. So before using width, let's use parallel here. So I want this face and this face to be parallel of each other. So you can see right now they are parallel, but it is so they are parallel. Now I can just click here and or I can make them coincident. So basically it is a coincident, so I will leave it to the coincident. And okay, now let's exit and try to move our component here, and yes, it is moved. Now next thing is to actually coincident this thing here. Now we can just go to mate and coincident here. Where is, yes, this is the coincident. You select the bottom surface of this one, and I can select this one. Now it is coincident on this. Okay, so the next thing is that we want this key to be in the center of this lock. So we can do this by defining the distance here. We can turn on the distance, and we can select these edges, and we can lock it easily. So we can decrease the value whatever we want, like 0.001 or something like that. And I can see it. So we'll have to measure the distance that we want, then we can apply. Now, so once we fix that, another way is, if you think if our calculation says that this key is in the center, you can just click it and lock it. So you can select both and just you can lock it, so it will not move. So both of will act as a single entity. So we are done with the lock. So we can apply our lock. So the lock will be applied here in the center. Now you can see we have to rotate it because both of these has to be aligned. So let's just work along with. So we can apply the parallel between this plane and this plane to make it in the same direction. So select this one, and you can see it has done rotating. And yes, coincident will also work. Just click on it and it is done. Now the next thing is to put this key in this here. Now okay, let's first make this plane and this plane parallel. Okay, now it is applied. Now the next thing that we want is to make it concentric, the center of this cylinder, and this one has to be same. So we select the concentric. Let's just select the edge, and in this case even the surface, so it is selected. Now you can say the key is applied, but the thing is the key has to be in the center. You know, if you look at this, sorry, not the key. So this part has to be in the center, the lock has to be in center. For example, this is actually touching this, and here we see there is a certain depth, so we have to keep the lock in center. To do that, we have another mate. So we can go to advanced mate and select the width. So in width, what it does a great help in centering purposes. So what I do, I just select this plane as a width, this and this one, and these two as a tab, and it will center it. And you can see it does a little shift and it is in center. So you can also do other things, but it is really good for the center purpose. Now you can see it is in center. And now the next thing is to apply these nuts and bolts. So it is gonna be easy. So first of all, we will go to the standard mates, and for example, and this assembly also has some intelligent system. It also detect automatically that what we want. You just, for example, if you just click on this surface and this one, it will automatically understand that we want to apply the concentric here, and we also want to touch this edge on this surface, so we can just click on the edge and click on the surface and it will touch it. So you can see most of the things are automatic. Now next is to apply this one to here. Now I can again click on the concentric and click here, so it is applied. Click done. Now next thing I want is to touch. Okay, so we can take the help of cross-section view here. So okay, let's come outside and select the cross-section view. Okay, I will do a little rotation right down here. Okay, this might work. Now I come here, so I select the mate as this is the bottommost point of the, and this is the bottom, so it has moved. When I get out of the cross-section view, you will see the work has been done. Now you can see there are 4 more holes, so you have option that you can import again those files and apply those screws here. Otherwise you can do, what you can do is you can just use linear component, go to circular pattern here, and you can select the component to pattern. I want to apply this nut and this bolt. You can select the direction. I want this direction. Now there are actually 4 quantities. Apply equal spacing and you can see it has been applied. So you can see this work it is completed. So basically it is done, and we can check using the movements if there is something like. Now you can see it is still rotating, that's why we see underdefined here in the bottom. So we can also log the rotation, but for the time being it doesn't challenge anything. So if you want to lock it, so you can either just click here and select the body and you can go for the lock. Now let's cover another example which has other assembly properties. Mates. So just import our files here. So I'll be using just these 2 as my files. For example, I import this guy and this one. So I need 2 of them, so I can make a copy, or I just import them again. So I'm importing them here. So let's just quickly do some mates here. So the not again, so I'm gonna apply this concentric mate between these 2. Done. Concentric mate between these 2. The planar surf, not, I want to apply the parallel here, and I also want to apply parallel here. Then I want to actually move this apart, something like here, so it can work. And I also move this one, can go here, move okay, so just right click here and select float, then also move it. Now let me fix few more things. So I am fixing this one in parallel with this surface. Okay, now what I want to do, we are going to see the one of the advancement that is called the linear coupler mate. So let me just show you. So for example, if I am just moving this and I am moving this one, so if we are working in assembly where we want to define a system where if I move this for like 1 meter, then they should move for 2 meters. Okay, so we can achieve that using the linear coupler mate. So we can just go to the mate and advanced mate and select the linear coupler, and you just select the planes which will be actually going to be moving, and you can just define the ratio, like I defined the 2:1. So if one of them Now their movement is now synchronized. So for example, if I move this one, you can see it just have gone half and it has completed the whole. So this is how you can apply the needle coupler mate. So this is pretty much useful in machines like in the assembly of 3D printer. Now let's discuss the so the next thing that we are going to discuss is the path mate. So I'll be importing this assembly file. Now let's just look into it, how we're going to do it. So path mate is used when you have a particular part, that is part 5 in my case, and you want to make it follow a particular path, that is part 4 here. So that's when we use the path mate, and it is used in things like 3D printer or everything. So that can be super useful to you. Go to advanced mate, select the path mate. Now it requires a vertex, and vertex has to be the part of that model which will move. So here in this model I didn't find any vertex, so what I did, I just added a point here using the sketch. So you can also do that. So we just go to, so we can apply the path using easily by just going to advanced mate and going to the path mate. So this is our part 5, so I select sketch 3, which is our component vertex. For example, this one, and I select this as a path. Now it says that please select path and the vertex from a different. So for the time being, what I can do, I can hide this sketch, so it is hidden. Now I select the vertex from the model. Now then for the path selection, I can again come here and select this one. I can make it visible and select this for the path. Now it's working. Now just click here. Now you can see there are a few more controls like pitch and yaw control. First let's just do it and randomly, and when you try to move it, look, it is rotating randomly and but following the path. So this is about the path mate. And in the assembly, so I have covered the standard mates, coincident, parallel, and these things, and will also cover the advanced mates. So mechanical mates are quite like advanced, so I'm not covering them in this tutorial. So this is so we have covered till now sketch, features, and assembly. And if you want to learn these things by the projects, you can go to our other playlists and you can learn from there. So see you in the next sections. So hello, welcome back everyone. In this tutorial I'll be telling you about the surfaces. So surfaces are the Solidworks entities which doesn't have any volume, they doesn't have thickness, and surely they doesn't have a mass. Surfaces are used in everywhere basically. If you want to research about the aerodynamic properties of a blade, or even if you look at the car chassis or any simple thing, then the surfaces are used there. So before going into detail like what are the surfaces and everything, let's just build surfaces. So you can see there is no option right now how to bring surfaces. So what you can do, you can just right click around any tab and go to tabs and select surfaces, which is here. So you go to surfaces and we can do it. So you can also make toolbar of surfaces just by right clicking and go to surfaces. So you can also have a toolbar, which is, you can see I can take it anywhere, so I just keep it in the side. Okay, it's here, just take it to the top. Yes, it's fine. Now let's start. So let's figure out how many ways are there to make a surface. So you can see I just roll down one step and I get a sketch, which I have already done because you know right now how to make a sketch and model. So the first way to make a sketch surface is by extruding it. So I have made a sketch of a rectangle, and I go to this extruded surface. I select the surface, and yes, now it's there. Now I can change the length of the surface, I can change the direction of the surface, and you can also select the ways to define the length of your surface extrusion, and you can also apply the draft angle here. So let's just apply a random you can see it's outward draft, and increasing. Okay, it looks much better, draft inward. Now you can also go for the second direction. So basically all of the things are like solid extrusion, and one thing that you will find different here, you have also option to cap end, that is to close the option, close the end of the surface. So yeah, look, it's closed whatever you select. Now here you can see this particular surface is closed, and when I click it back, it's unclosed. So I will keep it to closed and just enter. Now you can see you have a surface of a box. Now this is how you can make in extrusion. Let's figure out other options. I will be deleting it. Now next one is a revolved surface. To do that, I brought another text which is a line, another sketch act. So I select this particular first one and go for the, okay, let me take it here. So select the revolved one. Now I have selected my sketch which will be revolved. Now I select the axis of revolution. Now you can see revolution is also complete. I can select the angle which I want, and you can also do that in direction 2, which is from this perspective, 150 this side and 150 this side. Now I can mesh with the angle, so I will be turning out direction 2 and just click here, and you can see a pipe kind of structure is made. So this is how you do the surface revolution. I will be deleting it also. So we have discussed 2 ways. Let's discuss next is the let's go swept first. So I drop it down. Okay, next is a swept surface. So select. So as we have seen in the features bar here, for the swept we need 2 things. The first is a sketch, which will be a sketch profile which will be applied over the path. So the first is you select the sketch profile, and the second is the path, and you can see this sketch is swept along this path. And you can also work with the other option. For example, you can also apply twist here also. So you can just apply. So it will take time. So we have discussed 3 ways till now. So we have discussed 3 ways to generate surfaces. Now next is to use the lofted. So I will actually hide this sketch, 2 sketches, this one also, and I will hide this one, sketch 3 also. So next is the lofted. So I will also hide this plane. Next is the lofted surface. I select the lofted surface, and basically you just have to select these guys and you're done. And you can mesh with this pivot points, and you can just get out of it. You can also work with these constraints which I have already discussed in the feature section. Now just close it. You can also close the loft, that will close the surfaces, and you can see the surface as in font. Now next option is let's okay, delete it. Let's figure out others. Next one is boundary surface. Boundary surface is a little bit same. The difference is that in case of lofted surface you can also provide the guide curves. For example, if I want to provide a guide curve, you can provide through here. You can see here I can go lofted, I can select these sketches easily. Now you can see it looks like a simple surface. I can also add a guide curve, and you can see now the lofted surface is made, but the path is along the sketch 5 which I have already made. So this is it about the lofted surface. So I'm just gonna delete it. And in case of boundary surface, you cannot use this paths. Now I will hide this. Just right click and click hide. Also hiding this plane. Now let's figure out other options. And the next is the filled surface and the planar surface. So let's just discuss planar surface first. So planar surface is like if you have a closed sketch and you want to make a surface around that space, you just click it and enter, and it will be formed. And for example, you can also do the same to this rectangle and just click and done. Okay, so in the next part here, so let's explore a few other options. So yes, the next one is the offset surface. So if you have a surface and you want to make the same surface at some distance, you just select it. You can see there's a surface extended, and you can select it whether it's inward or outward. You can set the distance and you just click it here, and you can see an offset surface has been made. I will be deleting it. And another option is a ruled surface, which is quite important. So for example, if we want to, let's see what it does. First of all, when you click here and right click and select tangency, and also select this. Now you can see here, let's first select the tangent to surface. Now you can see it might seem like that it is a extrusion kind of thing, that you select edge of a surface and extrusion has been done. So basically it is like that. And you can select the distance from here, and you can also select the normal surface. Now it is normal to the original surface. So you can also choose it to be like an invert. Now this is what you can do. And next is the taper to vector. So here what you have to do, you have to select a vector. For example, if I select this vector, now I get in the next option to select an angle, that at which angle I want it. I can just click it and it's formed. Now there are few more options, and next is a perpendicular to vector. If I select this one, the perpendicular vector will be selected. And next is a sweep. Sweep is basically like the sweep that we have discussed here in the solid. It also needs a path, and so here the path is actually this particular edge corner of the surfaces, the original surfaces, and the angle is provided by us. So this is the angle, and you can provide length from here. Now trim and knit is chosen. When it is done, then redundant surfaces are deleted automatically. Now when you're done, you just I will leave it to the taper and just click it. So ruled surface is more like if you want to extend your surfaces in a particular direction or whatever, so you can do it. Next is delete surfaces. If you want to delete a face, you just click on it and select, it will delete it. Okay, so I have selected the patch, so I can just remove it and it will be just deleted. So other options, one of the important is the trimmed knit surface. So for example, let me hide this. So for example, consider that I have two surfaces, a surface plane 2 and surface plane 3, and I want them to like act as a single surface. I want to join them. So you can join them using the knit surface, but there is a condition that if you want to join two surfaces using the knit surface, they should have a common edge along with which they will be joined. So let me just go along the net surface, and you don't have to do a big thing. You just click on here and here, and it will be done. And when you click green tick, and you can see here is a surface net. Now even you can see there in surface body section you can see only one surface, and if I just take it above, you can see there are two surfaces. So this is what you can do using surface net. You can join multiple surfaces into one, and a few others are like extend is basically like just extending your surface along the uh, same profile. So you can define the distance and point and whatever you want. Now others include the trim surface. So let's understand how it works. So will be extending these two back first. So for example, if I just extend this, okay, it is good, it might work. Now I will be extending this surface also. So yes, so you can see, what if I want to cut this plane using this plane? Okay, so let's see how we can do it. Just go to trim surface. So trim tool, if I want to cut this surface, then this will be the trim tool, and you can select which piece do you want. So I am cutting with the help of it. So if I, for example, if I want to keep the bottom one, I just select it and click. Now I can see the top portion has been cut. So surface trim helps us to cut a surface using another one. Now next is untrimmed surface. Untrimmed surface you can understand by, for example, if I make holes here, like just let me make few holes here. So you can if I cut it, for example, if I perform so you can let's explore one option here. Trim surface, you go to the trim tool. You can also cut using the sketches. Now you can also cut using a surface. Now you get to choose which part do you want. For example, I want the external part. Now you can see I made hole here just with the help of a sketch. Now I want to fill these holes. So what we can do, there are multiple options. I can either go to the fill surfaces or the planar surface, but I will choose the untrim here and just select this, and you can see it's been filled up. Now an important one which is gonna take some time is the freeform tool. So I will delete this one and let's make a simple surface. So just take it back. Okay, I will be just making a filled surface, planar surface using the sketch. Now let's perform the freeform tool over this. Now freeform tool, you select the surface and go to the freeform tool, which is this one. In this tool you can change the shape using some points or curves. So first of all you select the face, then you make curves, then you select the points, and then what you can do, now I am adding, for example, you can see I am adding curve here and I am adding curve here. Now next is the adding points. So I am adding a point here, here, and in this line I add 2 points only. Now what I can do, when I'm out of it, just click on add point and you are out of it. Now you can see when I click on these points, I get an gizmo to change the location of this point. Now if I move these gizmos, it will actually affect the surface. For example, if I take it upward, you can see the whole surface has gone upward. Now for example, the only thing is that the control points you will have to define using curves, then points. You will have to already define the control point. Now you can see I have made a few changes in surface. Now I want to come to this curve. I just select this one, this point, and just do whatever I want. Now when you're done changing the shape, you just click here and it will be complete. So this is all about the surfaces. Surfaces are actually pretty much important. Now, so I've explored all the options. Now let's see you in other section. So hey guys, and welcome to the next section. So in this section I'll be covering the weldments. So if you do not have weldments in your tab, you can just click anywhere here and you can select weldment from the tabs. So this is, so you can click it to bring it or hide it. So weldments are actually used in the such models where we are creating some structures. So the first and foremost requirement for creating any weldment is that you need a sketch on which we will be working. So I'm changing my units to centimeters here, and let's just first make a 3D sketch. And if you have any doubts regarding the 3D sketches, I have already covered a section on 3D sketch, so you can go through it. So let's make a quick 3D sketch. So I'll be making a table. So we will actually apply the weldments on that table. So I'm just making a quick 3D diagram. You can also go for the 2D version of it, and by using multiple planes you can also make it. So I'm just making a quick sketch here. So to switch, okay, I am working in ZX plane, so I will just do it quickly. So I am making a table here. So okay, again one more. Okay, then let's just apply quickly the relations. So the first relation is that these four are the legs and they will be equal, and equal will work. They're also along y-axis. Sorry, just pressed. It's along y. Now next is that add relations. These three are also equal and parallel. Now these three are also equal and parallel, and these two are supposed to be perpendicular, and this is also perpendicular. Okay, we can complete it in one time because we have already applied the equal and parallel. Now let's just apply some quick dimensions here. So I'm choosing the length to be of around 50 centimeters, and the breadth, okay, increase it by make it 1 meter, so it will be 100 centimeters, and the width of 45. Make it like a 65. Okay, now increase the leg size here. So leg size will be around 45. So you can see the sketch is fully defined. Now let's just come back to weldments. So let's just get out of it. So let's just enter weldment, so we can create a weldment feature. Just click on it and we have created a weldment feature. So let's explore what we can do with weldment. So the first thing that we are going to see is the structural member. So structural members gives us a lot of options to apply the structures. So first we choose the standard which we want. So I'm selecting ISO. So let's just check every one of these one by one. So first I select the angle iron and I choose the smaller size, and when you choose here, then you click on this your sketches, and that particular profile with that size will be applied. Now there's a condition. You can see there is a group. So I have clicked on all these 4 sketches and it has been applied, but when I try to click here, it does not apply. It is because that we can only add in a single group. All the sketches should be continuous or they have to be parallel. So this is continuous. So for example, if I just clear it, I can apply it also. Okay, I can just apply it in this way, but I can also apply in parallel ways. For example, if I just click here, so you can see I can right now I can also apply in the middle way, because this is parallel or it has to be continuous. So let's just select the continuously. Now you can see I have applied our first profile, that is angle iron, and the size is 2020 cross 3. Next is let's just zoom into it. Now okay, let's just change all of these and let's see how they look. So I select C channel and select the size 80 cross 8. Now you can see how it looks. This is C channel, and but we are going to use a rectangular tube, so I am selecting the minimum size here. Now we can also change the corner style. So let's just so this is from where now you can see a lot of type for here. The first one is end emitter, where you can see a diagonal profile is made here. So this actually applies to the whole group. So whatever the group is here selected, then all of these properties will be applied to that. So just zoom into it again, and you can try whatever you want. You can see there is multiple types, so I will leave it here. Now the next thing is we can apply some distance here, that is for the welding distance. So we can apply anything, but I am leaving it at 0. You can apply it like 1 mm, 2 mm depending on the welding proposed by the designers. Next, one of the important is the angle. You can also rotate it. You can see as I click change the angle also changes here. So this is pretty much it, and let's just create new group. In the new group I apply here, but I cannot again select this one, so I also select let's select here square tube and select the minimum size. So in center I am using the square tube, that is group 5. Okay, now one thing you need to notice that, so whatever the selection that we will do here, that will apply to all the groups, but we can apply these properties which are below the group to individually to all of these. For example, if I select the square tube here, then the square tube will be applied to all of these group 4 and group 5, but I can change the angle in both of these. So let's just see here. So first I go to group 5, that is in the center, it looks fine. I go to group 4 and I bring back its angle to 0. Now let's make another group in which I will select the center one. So I find that okay, I select the size. Okay, everyone is changed. So I select rectangular and I select the minimum size. So you can see our center part is completed. Now let's come to the next part. Now we have to apply structures to the legs of the table. Go to structural member. So I will refer it as let's select pipe for this below one. So I go to select minimum size and create a new group. So I can add once because these are parallel. So I click here and it gets applied. Now you can change all of the properties if you want. Now you can see it is applied. Now we have a Weldment structure. Now there is a thing that you need to notice. Let me change the appearance here. So if I change it to glass, so for example, if I change it to glass, now you can see that these pipes are actually going inside the upper one. So what we can do actually, that we can cut these pipes so they end at the bottom plane of the upper structure. So that can be easily done using the trim and extend. So we click here that what bodies we want to trim. We want to trim these bodies, so select all of these. Now we can select that trimming boundary. We can select the bodies or we can select the face. So if we want to select the trimming body, then we have to select all of these. Otherwise we can just select the face plane, select our bodies to be trimmed, then select our face. And we don't want weld gap, and apply. So you can see when I select these pipes, for example, if this one I select, then I find only this one. And when we'll be creating a bill of materials, we will get the length of only this pipe, not the above one which we just trimmed. So this is a pretty useful way to work with this trim and extend. Now next feature is the extruded bows, which is pretty much same as a feature. So for example, if we need to make a plate somewhere, go to Weldment, and if we need to make a plate somewhere, then we can use this feature. So I can just click on it, and it's just normal one. You make a sketch on or something, and just you can, sorry, not here. So you make it and just go to Weldment and you can just extrude it, and this is pretty much normal. So you can also access this feature from features. So I'm gonna delete it. Now the next important that includes is the end cap. So we need to close our structures. Let me apply the different material. Let's just go to metal and apply different material, that is for example polystyrene. Okay, it's applied. Now let's come to end cap. So end caps are basically used for closing. So I want to close this pipe, I click here, and now you can see the end cap. So it's extra metal which is added. Now there are three options. I want to keep it outward, inward, or in between. Now internal, so I can also keep it internal. So if I keep it outward, then what happens is that the extra length of plate is added. But if I keep it internal, then this whole section of pipe will be deleted. For example, you can see this. Now you can see the plate and the pipe length is cut, and extra length of end cap is added. But if I choose the external, it actually just stays that way, and I can also use the internal version where it stays in the center. Now there are few more properties. Here I can define the dimensions. Let me go external. You can change the length here. Now there is another feature that is called thickness ratio. So let's just apply 0. So when we apply 0, the end cap covers the whole section of the pipe. The outer diameter of the pipe equals the outer diameter of the cap. But when I click here 1, then inner diameters of outer pipe become equals to the outer diameter of the end cap. But basically the value which is kept is 0.5, or just keep it internal. So keep it internal and 0. So you can see it's closed here. Now this can also be applied easily on all of these. We can just go in here and select all of the faces. So we have applied the end caps. Now next thing is the gussets. So gussets are the supporting structures which are added between two perpendicular or any kind of profiles, as long as they have an angle between 0 to 180. So for example, I want to apply a triangular profile here, and I select these planes, this and this plane. Now you can see I get a preview of the gusset, so I can change the dimensions from here. So whatever angle I want. So I can also apply a triangular, and I can also apply a multiple polygon. So we can choose the placement of this gusset, whether I want it at the center or the top or the bottom, and I can also apply some distance if I want offset. So I just keep it in the center and I can just apply it. Now you can see a gusset is applied. So you can see it is visible here, or you can see, go to cut list and you can find everything here. Now what's left is a weld bead. So there are two things in here, which is a weld bead, and another one is let me see, another one is a chamfer. So let's just first check out the weld bead. So if we want to represent that we are going to apply a weld along any structural member, so we can present that using the weld bead. So let's just apply metal also here. So we have whole structure in same visualization. So let's just click on weld bead. Now I can select it. Okay, so we can select the weld geometry or a weld path. So I select this circular profile, and you can see we have a visible weld bead. I can increase the radius of the weld. Now I can also apply that from what length to what length I want it. So I can select it. For example, like you can see now it is 0 to 0.69 just, or I can increase it. I can also apply the intermittent weld, which is at particular gaps. So I am leaving the values to default and just click here. Now you can see weld has been applied, and another weld folder is made. So this is about the weld bead. Now next features are extrude cut and hole widget, which are basically that can also be done if you go to here. So actually this is it for the weldment. So as a beginner, this is I think enough. So if there are actually more things that can be covered, and I will cover them in further tutorials. So this is it for the weldment, and if we just want to complete this table, we can just make a rectangle here with like dimensions like this, and just extrude it and apply some material like 1 centimeter thickness, and I think we're good to go. So this is it for this tutorial, and you can see when we apply a weld, we also get the welding symbol. So see you in the next. So thank you everyone, and this is it for this video. So other parts will be uploaded very soon. So if you have any question, or if you want us to work on something, then just let us know in comment section or on Instagram page, and please visit our playlists. They contain a lot of stuff. So yeah, see you in the next video.